Okay, hello and assalamualaikum everyone. So today we are going to continue with the subtopic 3.2, which is periodicity. So basically the subtopic 3.2 we will learn about the trends of our periodic table lah. Dia makin besar ke, makin kecil ke, kita punya atomic radius and so on. Okay, there are three different trends that we have. We have the trend of atomic radii across a period, maksudnya ke sini, ke kanan. Across the first row of transition metal elements or your D block elements. Okay, so that means that this is in period 3. And then down the group maksudnya ke bawah. So we want to know whether our atoms ni dia makin besar ke, makin kecil ke, makin besar lepas tu makin kecil, lepas tu makin besar ke, or whatever lah generally. Okay, so basically these two together we will analyse lah. Analyze why, what is the reason that our trends are that way. Okay, and then you are going to compare the atomic radius of an element and its corresponding ionic radius. So that means you are going to compare the size of your atom versus its anion, okay, dengan its cation. Okay, so depends lah on your element. Okay, so we are going to learn why. Okay, dia punya size atom ni lebih besar ke, atom ni lebih kecil ke banding dengan dia punya cation atau anion. Next, you are going to learn a new term called isoelectronic. So iso actually means the same. Electron maksudnya electrons lah, same number of electrons. So we are going to compare the radius of your isoelectronic species, maksudnya species with same electronic configuration. Okay, kita nak tahu dia punya size macam mana. Adakah sebab dia punya electronic configuration sama, dia punya size akan sama? So we will find that out. Okay, we will explain how. Next, we will analyze the variation in the ionic radii across period 2 and 3. Okay, so this is basically half of 3.2. So we will cover this in week 8 and the rest will be covered next week lah. Okay. Okay, so our atoms, okay, the size across the period, the size down the group, the size ke mana-mana, it has a general trend. So before that, we want to know whether we can actually measure the size of our atom. Can we? Okay, actually it is difficult to be defined, okay, the size of your atom, because your atom, it does not have a clear boundary. Dia bukannya satu benda yang bulat saja. Okay, why? Because your atom has an electron cloud. Okay, it is indefinite. So therefore, we will use the distance between two nuclei. Okay, maksudnya itu adalah plural untuk nukleus. Satu nukleus dengan dua nukleus jadi two nuclei in a molecule to represent the radius of an atom. So kita akan measure ni. This length is A. Okay, to find the radius, we bahagi dengan 2. Okay, so we will get the radius lah. Okay, so that is just what atomic radii means. Okay, radii itu defined by what? So generally, okay, down the group in your periodic table, okay, the atomic radii will increase. So maksudnya, the size of your atom down the group will increase. Makin lama makin besar. Okay, so a way for you to remember is to remember bukit, okay, atau gunung. So going down the gunung, going down the hill, dia makin lebar. So size atom awak makin besar. Okay, so next, across the period, maksudnya across the period 1, period 2, period 3, okay, across satu period tu, the atomic radii decreases. Makin lama makin kecil size awak punya atom tu. Okay, so yang ni kita boleh ingat by the shape of a flag. Okay, a triangular flag. Ke kanan ni makin lama makin kecil. Okay, macam ni flag. Okay, so next is when across the period of D block, okay, or your transition elements, the change in your atomic radii is very small. Okay, why is that so? Because bila awak going to the right, okay, awak tambah lagi banyak proton, maksudnya awak punya elektron pun makin banyak. So you are actually feeling your electrons in the inner shell, 3D orbital, instead of your outermost shell, which is 4s. So yang ni kita akan find out later lah, okay, in more detail. Why dia small change saja in atomic radii, okay. So how are we going to explain, okay, the trends across the period, down the group, across the first row of D block elements? Okay, there are two factors that actually affect the size of your atom lah. Okay, so the first one is effective nuclear charge, the actual nuclear charge that is felt by your electron. Okay, so we want to know the effective nuclear charge that is experienced by the valence electron sebab dia yang kat luar sekali. Okay, so kalau siapa kat luar sekali tu, kita nak tahulah berapa kuat dia punya effective nuclear charge yang dia rasa. So kalau tinggi, maksudnya dia kena tarik dengan begitu kuat lah. Okay, so across the period, we will use the formula PSAS to explain effective nuclear charge. Okay, so the other factor is your principal quantum number, N. Okay, so N is your energy level, your shell, okay, your period, alright. Your highest N, okay, the principal quantum number of your valence electrons, will explain down the group. Yang ni akan explain across period. Alright. So, down the group, we will use the formula PSAS. Okay.
So, I will explain to you what PSAS is now.
So, P is proton, Z is your ZeV. Okay. A is attraction between nucleus and valence electrons. S is the size of atom. Okay, so down here P sama je proton, but S is actually shielding effect ataupun
screening effect. Okay.
A is attraction between nucleus and the outermost shell electrons, and S will be the size. Okay, so let's go. So effective nuclear charge, or ZeV. Z effective. Okay, Z itself is a nuclear charge. EFF is effective. So your electrons around the nucleus, it experience difference in the nucleus attraction. Okay, so maksudnya elektron yang dekat paling luar, elektron kat sini, elektron kat sini, elektron kat sini. Okay, diorang akan experience different effective nuclear charge. Okay, so your nucleus ni, okay, it has protons in it, so it will have a nuclear charge. Nuclear charge, okay, since proton is positive, it is actually the force that will attract your electron towards the nucleus. Okay, dia akan tarik. So nuclear charge tu basically a force lah yang tarik your electron towards the nucleus. So, electrons that are closer to the nucleus, okay, let's say the electrons in the inner shell, will experience a greater force than those that are further away. Betul tak? So, siapa yang lebih dekat, dia akan rasa lebih banyak lah efek dia. Okay, dia akan kena tarik dengan lebih kuat. Okay, banding dengan siapa yang dekat luar sekali tu, paling jauh tu. So, within a period, as ZeV increases, your radius decreases. Okay, so what is ZeV? Kenapa tiba-tiba kita cakap pasal ZeV pula? Right, so this is because we are going to talk about shielding effect juga. ZeV will take account of shielding effect, while your nuclear charge is basically just nuclear charge that is released, that is coming from your nucleus. Okay, so effective nuclear charge is the actual or net nuclear charge, okay, nuclear charge yang betul-betul experienced by an electron, okay, as a result of shielding effects due to presence of other electrons. Okay, so analogy dia macam ni. Imagine you are at a concert, right? So dekat stage tu, you have your performer. Okay, so during a concert, contoh tengah excited, tengah high, bukan high lah, macam happy kan, awak punya performer tu dia baling air. Okay, dia baling air dekat audience. Okay, So sekarang awak punya audience tu, okay, this is your performer. Your audience tu ada yang dekat barricade kat depan sekali. And then ada yang dekat standing area yang belakang sikit, row yang ke belakang. And then lepas tu ada yang dekat sitting pula, kat belakang lagi, jauh lagi. Okay. So awak punya performer tu, dekat stage tu, adalah proton dalam nukleus. Okay. So dia baling air, maksudnya dia akan ada nuclear charge. Okay. Dia ada Z, dia ada nuclear charge. Okay. So siapa yang dekat depan sekali ni, okay, dia akan rasakan effective nuclear charge yang paling tinggi. Okay. Sebab dia tak ada kena block ke apa. Okay. Dia tak ada kena block. Dekat depan sekali. Dia akan rasa air paling banyak kena simbah kat muka dia. Okay. So, yang dekat second row ni, okay, dia akan rasa kurang sikit air tu. Betul tak? Okay. Why is that? Because dia kena shield dengan manusia, audience yang dekat inner shell ni. Okay. Diorang ni yang kat dalam ni, they are blocking orang yang dekat second row ni daripada feeling the full nuclear charge, full simbahan air dekat dia. Okay. So that is called, they are being shielded by the electrons atau audience in the inner shell at the first row barricade. Okay. So, electrons atau audience yang dekat outermost seat ni, outermost shell ni, apalah yang dia rasa? Ada tak dia rasa? Mungkin adalah sikit satu titik kena kat dia. Kan? Okay. So, basically, the electron at the outermost shell, okay, it will feel the lowest effective nuclear charge. Effective nuclear charge, ZEF yang paling rendah sebab dia furthest away from the nucleus. So, audience yang kat belakang ni, the furthest away from the performer. So, dia tak rasa lah air tu dekat muka dia. Okay. So, that is because it is being shielded. Okay. It is being shielded by the electrons in the inner shell. Okay. Ada banyak lagi orang lain yang block diorang ni daripada rasakan the full nuclear charge. Okay. So, biasanya when we are talking about effective nuclear charge dengan atomic radius, we will talk about the effective nuclear charge of the valence electrons. Electrons yang dekat luar sekali. Dekat shell yang paling luar. Okay. Okay, so there is a formula that you can use to calculate the effective nuclear charge. That is using the formula, okay, Z, your proton number, minus S. So, S is basically shielding effect lah. Okay. So, shielding effect tu oleh siapa? Other electrons. Okay. Selain daripada awak punya electrons in the outermost shell. So, maksudnya siapa yang dekat dalam inner shell. So, the number of electrons filled at the inner shell. Because electrons ni yang akan shield electron dekat luar sekali ni daripada merasakan the full nuclear charge. So, bila kita tolak, okay, proton dengan number of electrons yang dekat dalam inner shell, then we will know the actual nuclear charge that is felt by these electrons. Okay, faham kan? Alright. So, when talking about a cross period, we will be using the formula mnemonic, I don't remember. PZAS. Okay. So, P is the proton number. So, when the proton number or nuclear charge increases, okay, the effective nuclear charge will increase. So, as the effective nuclear charge increase, therefore, the force of attraction between a nucleus and outermost electron will increase. So, maksudnya elektron awak yang dekat luar tu, makin lama across the period kan, makin lama lagi banyak proton, lagi banyak elektron. Okay, nuclear charge increase, effective nuclear charge pun increase. That means that your outermost electron your electrons in the valence shell is pulled even more stronger lah to the nucleus. Okay, the force of attraction makin stronger. So, therefore, kalau dia makin kena tarik dalam, then the size of the atom will decrease. Okay, so that is PISAS. So, you are going to use this to explain the size of atom across period. Okay, across period, proton number increase and blah 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 blah. Okay, you can use the terms proton number and nuclear charge interchangeably, although it does not exactly mean the same thing. Okay, so bila protons lebih banyak, then your nuclear charge will actually increase because protons yang memberikan nuclear charge tu. Okay, tapi like selalunya you can use this interchangeably lah. This point ni kira macam point yang sama lah, but it's better to write both of them. Okay, so right here we are going to look at how this translate to our atoms in period 3. Okay, period 3. So ni adalah atoms in period 3. So from sodium to silicon, okay, we can see that the number of protons are increasing across the period. Alright, so if we count the effective nuclear charge, okay, for each of the elements, we find that sodium will have +1 effective nuclear charge because apa? Z minus S. So what is your Z? Your Z is 11, number of protons. Tolak dengan the number of electrons in the inner shell. So ini outermost shell. Okay, so we are going to ignore that. So kita akan ambil the number of electrons dalam inner shell. So we have 6, 2 and 2. So that will be 10. So 11 minus 10, you will get +1. Alright, so that is your ZEF for sodium. Magnesium is +2, aluminium is +3, silicon is +4. So you can see that across the period, the effective nuclear charge is, okay, across your period increasing. Okay, so therefore awak sambunglah dengan point lain, attraction between nucleus and valence electrons becomes stronger. So your atomic radius decreases across the period. Alright. So next, we are going to talk about across the first row of transition elements. So this is basically your D block elements. Alright. So your D block elements maksudnya, okay, awak punya elektron, dia akan kena isi the last electron, okay, your electrons will fill in the 4s orbital first, okay, and then baru 3d orbital, betul tak? Okay, tapi awak punya 4s ni still dekat luar, faham tak? So you have 3d, okay, and you have 4s. Tapi according to Afbau, you will fill in this orbital first, okay, isi elektron dalam tu, and then baru isi elektron dalam 3d orbital, betul tak? Okay, so across the first row of transition elements, the atomic radius of transition elements is constant. Maksudnya, there is only a small change in atomic radii across your D block elements. Okay, why is that so? Because, okay, across the first row, electron is added to the inner 3d subshell. Okay, so it is not added in the 4s orbital. So your number of electrons in the outermost subshell, which is 4s subshell, will remain constant. Sama je. Okay, so bila awak add in electrons kat dalam your 3d orbital tu, okay, makin lama makin banyak. Okay, basically awak punya 4s electrons in the outermost shell will be even more shielded from the nucleus by the electrons in the 3d orbital. Okay, So your inner 3D electrons will shield the outer 4s electrons from the nuclear charge more effectively than the outer shell electrons. So what does that mean? That means that shielding effect, awak punya elektron yang kat luar ni, dia akan experience even more shielding effect when you add more electrons, okay, when going across the period. Okay, so across the period tu, awak punya shielding effect lebih increase. Alright, so even though your nuclear charge makin lama makin tinggi, it is actually cancelled out by the screening effect of your 3D orbitals, 3D electrons in the 3D orbitals tadi. Okay, so bila dia cancel out kan, okay, awak punya Z effective, okay, bila kita tahu yang Z, awak punya proton makin increase, okay, and awak punya shielding effect pun makin increase, tapi dua-dua ni besar value dia. Bila tolak, awak punya Z effective, dia punya value nak dekat sama je. Okay, so your Z effective, your effective nuclear charge across the period is constant. Okay, it's constant, sama je. Okay, so therefore, the atomic radii does not change very much. So that's why the size of your elements across the first row of transition elements does not change very much. Okay, so here we can see, alright, going from scandium to zinc, alright, across the first row of transition elements, okay, you fill in electrons in the 3D orbital instead of the 4s, right? So you are filling in electron in the inner shell. Okay, when you are filling in electrons in the inner shell, okay, your 4s electrons will experience even more shielding effect. Okay, will be more shielded. Will be more shielded by the electrons in the 3D orbitals. Alright, so bila awak kira awak punya Z effective kan, okay, you will find that you get a constant value from scandium to zinc. Okay, so and researchers find out that the radius of your elements, transition elements in the first row, is almost the same. Okay, dia tak banyak beza pun. Alright, so itu adalah explanation lah untuk atomic radii across the first row of D block elements. Alright, okay, the next factor that will affect the atomic radii, specifically for going down the group, okay, will be principal quantum number of your valence electrons. So maksudnya this will be your highest n. Okay, okay, so this one we will use to explain the trend going down the group. Okay, so moving down the group, the proton number increases. Okay, ni point penting, you have to have this point. Okay, so going down the group, okay, we know that the number of shells also increases. So daripada satu shell, lepas tu ada 2 shell, sekarang ada 3 shell, lepas tu ada 4 shell. Okay, makin banyak shell, okay, going down the group because your n is increasing going down the group here. Okay, that means makin lama makin banyak kan, makin lama makin banyak shell. Okay, there are the more inner electrons are present to shield the valence electron yang kat luar ni, okay, from the nucleus. So therefore the shielding effect or screening effect increases. Okay, so what happens then? The electrons dekat luar sekali ni akan tak dapat banyak attraction lah. Okay, sebab dia makin lama makin jauh, dia lebih shielded. So the attraction between the nucleus and valence electrons decreases. Therefore the atomic radius decreases going down the group. Okay, so the formula is P SAS. Okay, So proton number increase, shielding effect increase, okay, atau shell increase, shielding effect increase. So the attraction between your nucleus and valence electrons will decrease, okay. Jadi bila dia decrease, maksudnya awak punya size of atom makin lama makin besar lah going down the group. So ingatlah awak punya gunung tu, turun gunung ni, turun bukit ni, dia makin lama makin lebar. So dia makin lama makin besar size dia. Okay. So the key point here banding dengan tadi tu Z kan. Z kita cakap pasal effective nuclear charge. Here we talk about shell or shielding effect. Okay. So that is for going down the group. Alright. So yang ni I think you can read it by yourself and analyze the graph here yourself. Okay. So here we're going to look at this example. Okay. Let's say if they ask you to arrange the following atoms: phosphorus, silicon, and nitrogen in order of increasing radius. So you know that these are all your atoms. Okay. So you are going to explain the trend of atomic radii. Okay. So first what you need to know is, from here you need to know the number of proton. And then you find the number of electron. And then you can know the electronic configuration. So once you know the electronic configuration, you can find the group, okay, and period of each of the atoms. Okay. Lepas tu nanti awak akan dapat lah nak susun dia macam mana. Kalau dalam periodic table dia nampak macam mana. Okay. Once you find this, alright. So we are going to compare atoms of the same shell dulu. Okay. So a point that I want to sampaikan is that, okay, the shell, okay, will be more significant in telling the size of atomic radii lah. So maksudnya if banding dengan group, okay. Let's say shell 3 ke 3 and 4, okay. Let's say contoh saya tak ingat. So for in this case kita akan, we know that silicon and phosphorus are much more bigger than nitrogen because silicon and phosphorus have 4 shells, have more number of shells. Okay. So maksudnya compare dulu these two yang ada the same shell ni dulu. Okay. So just use this ayat, okay, baca and try to apply in your question tutorial. Okay, ini sambungan explanation dia. The second thing to do is to compare group pula. Once you compare between the shells, you can compare for group pula. Okay. Alright, so these are exercises you can do.